Okay, this is part 2 of your review packet. So it has to take the fourth root of a to the 12th. You could write out 12 a's and circle 4, 4, 4, and that would be 3 groups. So you could say a to the third, or you could write an absolute value of a to the third. Because if a was negative and I took it to the 12th power, it would become positive. And when you take the fourth root of a positive number, you would then get a positive number. So I will take either. You don't have to do this. Here, if you took 256 and broke it down, you get 4, 4, 4. You need a group of 4. And then if you have 12 groups, 4 groups of 12 groups, that is 5x minus 2 to the third. Now, since it's an even root and an odd power, you could do this, or you could just write it how it was. I don't care either way. Here, this would be x squared, and here, this would be y to the first. You could leave it like this, or if something is squared, it will never be negative. You could do this or this. If you're like, this whole concept doesn't make much sense to me, just let it go. The fifth root of 32 is 2 because there are 5 2's. And then here, if it's to the 15th, fifth root, it's a to the third, b to the second. You wouldn't use absolute values because if you take a fifth root of a negative number, you can get a negative. Okay, here, same thing. I like to separate that negative 54, separate, because you know the cube root of negative 1 is negative 1. 54 breaks down into 6 and 9. And you need a group of 3, so 3 comes out. And then 2 would stay. Okay, x to the 6th, y to the 11th. Well, that would be 2 groups. So negative 3, 2 groups. There are 11 divided by 3, no bueno. 10 divided by 3, nope. 9 divided by 3 is 3. So that would leave inside, don't forget your 3 here, it would be 2x squared. Yeah, yucky. That's your answer, though. Okay, you have to rationalize your denominator. So pretty much, this is your answer, but you're not allowed to have radicals in the denominator. Can you divide by something that never ends? No. So mathematicians just kind of agreed upon you have to rationalize or make the denominator an ending number. So if I take the square root of d to the 9th to the bottom, I have to do it to the top because anything divided by itself is 1, so I'm not really changing it. And you get c to the 5th, d to the 9th over d to the 9th. But you can keep breaking this down. I get 1, 2, with a c left inside, 9. I would have 1, 2, 3 groups. The d left here, and then d to the 9th. And then these would cancel, and I get you the 6 on the bottom. Okay. All right, here, you'd have to do the fourth root on the top and on the bottom, but wait. Since this was a square root, it's being squared. Since it's a fourth root, you need 4 total. So I would need 3 more of these. So if I do this on the bottom, here, let me do it over here. Kind of ignore this for a moment. If I have this here, I'd have to do it to the bottom and the top 3 more times for a total of 4 fourth roots. You wouldn't do 5x, that doesn't even make sense. What you do to the bottom, you have to do to the top because that's technically a 1. And if you multiply something by 1, you're not changing it. So the bottom just would turn into an 8y. If I have a 4 fourth roots, they cancel. Here though, did I write 3? Why did I do that? Okay, you need a group of 4. Well, 8 is 2, 2, 2, 2, 2, 2, 2, 2, 2. So I need a group of 4. So if this is 2, 2, 2, and this is 2, 2, 2, and this is 2, 2, 2, 1, 2, 3, 4, 1, 2, 3, 4. So that would be a 2 on the outside and another 2 on the outside, which is 4. There's 3 y's and an x and a 5. Oh, and a 2. So it'd be 10 inside. So it'd be 10. The answer key is on in a PDF file on the classwork. If you're like, what is this? I'm just trying to show you how to do it. And then there'd be a y to the 3rd. And this is a 4th root. And then this would simplify. This one's mega. Okay, 10x y cubed, 2 on the bottom. Bada bing. Let me know if you have problems with that. Okay. This next one, 3 times 2 is 6. 36 and 6 is 6, 6, and 6. And x, x, x. I'm breaking it down rather than putting it together because I know I'm going to have to take them out anyway. And I need groups of 3. 1, 2, 3. So I have a 6 on the outside. Take another 6 out. Take a y out. Take an x out. So 36xy is your answer. The end. Okay, down here. Okay, this is going to be 2, 2, 3. 2, 2, 2, 2, 2. This is 9 times 8, or 2, 2, 2, 3, 3. Take this out. It's going to be 18 root 3. This is going to be 20 root 2. This is going to be 6 root 2. So this is going to be 18 root 3 plus 14 root 2. The end. Here you're going to FOIL. Boop. Boop. 7 root 2, 4 root 6. That's 28 root 12. You know what? These are going to come in handy when you have pre-calc. You're going to reflect back on these. I'll keep them up. Next one, 7 times 3 is 21. Root 2, root 12 is 24. I'm just going to leave it unsimplified for the moment. This is going to be negative 12, root 18, and this is going to be negative 9, root 36. Okay, then you have to clean this up. Boy. Okay, 12 we just learned is 2 root 3. So if I take a 2 route, it's 54 root 3. This is going to be 4 times 6. So take a 2 out, 6. That's going to be 42 root 6. I mean, there's a lot more work to it, but I don't have a lot of space here. You're probably going to need paper. This is going to be 3 times 6, which is 3, 3, and 2. So take the 3 out, 36, 2. And this one's going to be a 6, so 6 times 9 is 54. And there's no order to this. I don't care what order you put it in. They're all different. They can't combine. Okay, this is a little bit different than this. You have to rationalize the denominator, but I can't just multiply by root 3 because it'll also transfer over to here. So we have to multiply what's called the conjugate. We did this when we did I. Some of you might remember. So to get rid of the radical, I have to multiply by its conjugate. You FOIL the top, you FOIL the bottom, and you'll see the answers on that PDF file. Okay. When you FOIL, you're going to get 3, negative 6 root 3, positive 6 root 3. They will cancel, and then 36. And you'll get a pretty number. And then the top's not going to be pretty, but that's fine. We don't care about that. And then just simplify as much as you can. Here, they're both the same root, so we can just do 64 divided by 4. 4 goes into 6 once, and then 4 goes, so that would be 2, 16. 5th root is 16. Can we break that down at all? Well, 16 is 2, 2, 2. Nope, we can't. So that's your answer. Here, nothing more you can do unless you want to do it this, but it's kind of pointless, so you can just leave it like that. Here, this is 4 to the 3rd, and then the square root of that. 4 to the 3rd is 16, 64. Square root of 64 is 8. 24 divided by 8 is 3. Negative, so it's 1 over 32. That's the square root of that, which is 1/2, 1/2, 1/2, 1/2, 1/2. So take a pair out, take a pair out, 1/2, so it's a 4th with square root of 1, 1 over the square root of 2, but you can rationalize the denominator. So it's going to be square root of 2 over 8. If you didn't like this one, you could just have done it this and done the square root of 1 over the square root of 32 and multiplied the bottom and the top by the square root of 32 and then simplified. Sorry if I'm talking quietly. Ezra's in bed. Okay, last page. So how we usually do this in class is you guys can usually do this. So I make this like your bell ringer for the lesson. And almost everybody gets it right, but there's like one little part here and here that people don't get. So I'll have to look. Do we even have notes for this section? We might not even have notes for it. If we don't, that's why, because it's in the review. Oh, no, we do have notes. No, we don't. Okay. All right, so we're just solving equations. The only difference is now we're dealing with radicals. Get rid of 6. Square both sides to get rid of the radical. Subtract 1. Divide by 3. And that's your answer. Here's the problem that we have with these. When you get rid of a square root, you're now solving it like it's a linear equation. Is it really a linear equation? No, it's actually radical equations. And linear equations have no restrictions. It's all real numbers. They're beautiful. They're lines. Here, though, we have restrictions. We can't have the square roots ever be negative. So will 8 work? You could plug it in and check, or just think logically. 8 will never make this negative. So that's your answer. That's why it says check answers. Here, you square both sides. Now you've created a linear equation. So when you get your answer, you have to make sure that it'll work. 9 is nice and positive. We'll make everything pretty. You're good to go. Here, subtract 2. Divide by 4. This is taking the square root, z to the first square root. When I square both sides, I get a 4th. Now, plug it back in to see if it works, because if I put a 4th in here, what's the square root of 1/4? It would be 1/2. So does 1/2 times 4, 2, plus 2 give you 0? No. So this is extraneous. It's called extraneous solution or an extra solution. Okay. So therefore, no solution exists. You don't have to write extraneous. You can just say you got extraneous. You don't even have to write that, or just no solution. Let's try this one. Add 5 to both sides. Cube both sides because it's being cube rooted. Subtract 10. Divide by 5. So 5 goes into 11 twice. 1, 5, 3, 23. When you plug back in, it should work. Okay, inequalities. All right. Subtract 6 from both sides. Divide by a negative. Remember to flip the side when you divide. Okay. Square both sides. Subtract the 1. Okay, that's your answer. However, since this is an inequality, versus an equation. We're not just getting one answer and having to check it. We're saying, does everything greater than 4 work? Well, if you look, as long as 2y plus 1 is greater than 0, we're okay. Oh, I have to be greater than negative half. Am I? Yeah, I'm greater than 4. So you're good. Okay, here we're going to do the same thing. Square both sides. Add 7. I have to be less than 43. Okay, well, we're not just talking about 43, we're talking about every number less than 43. So I can be 40, I can be 10, I can be negative 5, I can be negative 4, I can be negative 3, negative 100. Let's make sure. Well, as long as b minus 7, the radicand, is greater than or equal to 0, I'm okay. Oh, well, it's telling me that I have to be greater than 7 in order for it to work, and the overall solution has to be less than 43, so I'm stuck in between them. I have to be less than 43, but hold up, I can't be less than 7. So I have to be within there. And you can try those numbers and they'll work. And lastly here, subtract 5, and then square both sides. Oops, minus. And then divide, and you get 3.5. So my answer is less than 3.5. So could I be 0? Could I be negative 10, 20? Let's check. As long as 2y minus 7 is greater than 0, we're okay. Well, it's telling me I have to be greater than 3.5 in the domain. My overall stance is telling me I have to be less than 3.5. So those contradict each other, so there's no solution. Okay? And that's it for the chapter review.